Hey Vsauce, Michael here, coming to you from my hotel room in London with a little camera that I taped to a bunch of furniture I stacked up, which is better than nothing, and as you can tell from the title of this video, it's also what we're going to discuss. Nothing. Can there ever be nothing? I mean, we're surrounded by matter all the time. Even this glass is not empty. I know you might think there's nothing in it, but it's full of air, and air is packed. 1 cubic centimeter of air contains almost 30 quintillion molecules. But if I remove the air from this glass, I can create what is known as a vacuum, an awesome word that uses a double U but not a W. The challenge, however, is removing all of the air. To this day, the best scientists have been able to do is to create what they call an ultra-high vacuum. At this point, 1 cubic centimeter of space contains not 30 quintillion molecules, but a mere and amazing 100. To put that in perspective, a vacuum cleaner like you use at home hardly changes the thinness of the air at all. In fact, if you use a vacuum cleaner at sea level, the vacuum created inside the operational part of the machine only has the thinness of air found in Denver, Colorado. If you want thinner air, if you want even fewer particles per cubic centimeter, you're going to have to leave Earth. But before we go too far, let's talk about high altitude flying. When you're in an airplane 30,000 feet high, the outside air is very thin and dangerous, so by law, the airplane must keep the inside of that commercial aircraft pressurized so that it only feels like you're no more than 8,000 feet high. The reason it's dangerous is that when air gets that thin, there's not enough oxygen for your brain. This man is about to remove his mask temporarily and with supervision in the actual thinness of the air around him. Within less than a minute, he suffers from hypoxia, a lack of oxygen. And even though he appears to be awake and alert, when told to put his mask back on, or else he will die, he does nothing.
Put up the switches, or you will die. Put up the switches.
But a lack of oxygen, a lack of air, a lack of matter can get even more dangerous when you go above 60,000 feet, about 19,000 meters above the surface of the Earth. This limit is known as Armstrong's limit. We all know that the boiling point of water decreases as your altitude increases, and at Armstrong's limit, the boiling point for your own blood drops all the way down to the temperature of your own body. If you reach that altitude without wearing a special suit, bubbles will form inside your blood and your body will inflate to twice its normal size. But because your internal organs and your skin are flexible, you won't explode. So let's talk about outgassing. Outgassing is why it's so difficult for us to reach an ultra-high vacuum. If you remove so much air from this glass that there's fewer than 100 particles per cubic centimeter, the glass itself, or whatever material your chamber is made out of, will start to lose its own trapped gases. But materials don't need to be inside partial vacuums to outgas. It happens all the time, and is especially noticeable in confined spaces. For instance, a car. All of the adhesives and chemicals used to make that car will outgas and collect inside, creating what we know as the new car smell. Alright, time to leave Earth for good. Let's go into the space between planets. Now remember that in a laboratory, the best vacuum we've been able to create is about 100 particles per cubic centimeter. Well, between the planets and our solar system, there is space that only contains 10 particles per cubic centimeter. And if you leave our solar system into interstellar space, you're only going to find about 1 particle per cubic centimeter. The real winner, though, is intergalactic space. Leave the Milky Way altogether, and you can find regions where there's only 1 or 2 particles per cubic meter. Okay, that's cool and all, but would it be possible to find a region of space where there is absolutely and literally nothing, no matter at all? Well, according to quantum mechanics, no. First of all, you've got gravitational and electromagnetic fields that extend forever because the particles that cause those fields to happen have no mass whatsoever. And this is what's really mind-blowing. there's a thing known as virtual particles that's happening all the time, even around us right now where there's no vacuum. These virtual particles come into existence and then disappear. And we believe they exist for a couple of reasons. One big reason is the fact that our universe continues to expand, even though that shouldn't necessarily happen. Where are we getting that extra force that pushes it, that causes it to keep expanding? Well, these particles that pop into existence and disappear may be the answer. Even crazier is an effect we've observed known as the Casimir force. If you put two pieces of metal nanometers apart inside a vacuum, they will be pushed together. One of the most popular theories for why this happens is that these virtual particles popping into space and then disappearing are actually reflecting off of the metal. But because the plates are so close together, particles with wavelengths longer than that gap don't get reflected. So there's more virtual particles pushing on the outside than the inside, and the metal plates contact. I know these concepts have gotten pretty crazy, but rest assured that really all it means is that whenever you feel down and feel like nothing matters, you're scientifically incorrect. Nothing matters. There can't be nothing. There's always matter. There's always something. And as always, thanks for watching.